Time traveling is not a new concept. It has fascinated humans for centuries. And why not? Well, for some, it's a way to undo their biggest regrets. Maybe to ask for forgiveness for something they did that is unforgivable. For others, it's about rekindling lost connections and meeting their loved ones, and then there are those who want to change the course of history. But let's be a bit scientist. Can we really travel back in time? Well, stay with us to find out, because today, we are going to explore 15 brain-blowing theories about time travel, and trust us, they will shock you. Number 15, general relativity. Let's talk about Einstein. The guy wasn't just a genius. He basically rewrote the rules of reality. His theory of general relativity explains that time and space aren't separate. They're tangled together into something called space-time. Picture it like a giant stretchy sheet, and every massive object, stars, planets, you after a big meal, creates dents in that sheet. Those dents are what we call gravity. Now here's the cool part. Einstein's math says space-time can bend so much that it might even fold. If you could create a shortcut between 2 points on that sheet, you'd have yourself a wormhole, a literal tunnel through space and time. It's basically like a cheat code. But don't pack your bags for the past just yet. It requires something that maybe we don't know exists or not: dark matter. And if you're thinking of building a wormhole with atom bombs, well, you'll need trillions and trillions of them to even make a tiny dent in space-time. Number 14, the block universe theory. Time doesn't flow, it simply exists. Every moment from the beginning of the universe to its distant future is already laid out like chapters in a book. This is the essence of the block universe theory, where the past, present, and future are all equally real. This perspective shifts how we think about time travel. Instead of going back or jumping forward, you'd simply step into another part of the block. You're not rewriting history or changing the future. You're just experiencing a different part of the timeline that's already there. It's a strange concept to wrap your head around. It suggests that free will might be an illusion and everything is already predetermined. But it also neatly avoids any messy paradoxes, since nothing can actually be altered. If time travel ever becomes a reality, this theory might explain why it works the way it does: fixed, unchangeable, but accessible. Number 13, the butterfly effect. Now this theory is pretty famous. Small things often go unnoticed, but what if they held the power to change everything? That's the butterfly effect. This idea that the tiniest action, like a butterfly flapping its wings, could set off a chain reaction that leads to something massive, like a hurricane on the other side of the Earth. It's both mesmerizing and unnerving. Now think about how this applies to time travel. Let's say you went back in time and moved a pebble. Maybe that pebble would have tripped someone who went on to invent something good. Or worse, what if that small action led to a completely different timeline where you don't exist? The possibilities are infinite, and that's the danger. Even the smallest nudge can throw everything off balance. The butterfly effect reminds us that actions, no matter how minor, really matter. And when you combine that with time travel, it's a chaotic cocktail of endless what-ifs and consequences. Number 12, the Novikov self-consistency principle. Time travel sounds exciting until you realize how messy it can get. What happens if you go back and change something big, like preventing a key historical event, like World War I? Would reality unravel? The Novikov self-consistency principle says no. According to this theory, the universe has a way of self-correcting. No matter what you do, your actions in the past would already be woven into the timeline. Think of it like this. You travel back in time to stop a disaster, but every action you take leads to the exact circumstances that caused it in the first place. It's as if the universe gently nudges events back into their proper order. You can participate, but you can't rewrite the script. It's a humbling thought. Even with time travel, you're not a god rewriting history. You're just another player in the grand narrative, bound by the rules of the universe. Number 11. Black holes. Black holes are like the universe's ultimate "do not enter" sign. Their gravity is so intense that not even light can escape, which is why they're pitch black and, frankly, a little terrifying. Scientists think black holes form when massive stars collapse under their own gravity, or when stars collide. Whatever goes in doesn't come out. It's like a cosmic one-way street. But here's the time travel kicker. Near a black hole, gravity slows time down. If you could orbit one without getting sucked into the event horizon, basically the point of no return, time for you would pass much more slowly than it does for people on Earth. A year near the black hole might mean decades fly by back home. You'd return younger than your friends, but don't expect a warm welcome. They'll probably be too busy complaining about inflation and how much coffee costs now. While this sounds exciting, no one's tried it yet. Black holes are just a mystery of the universe. Number 10. The many worlds interpretation. Now this one is also a real mind bender. The many worlds interpretation basically says that every time a decision is made, the universe splits. Pick chocolate ice cream instead of vanilla. Boom, there's now a universe where you picked vanilla. It's like reality is one giant branching tree with infinite possibilities. Now, imagine time travel in this scenario. Instead of screwing up your own timeline, you just create a new one. Say you went back and stopped some big historical event. It wouldn't change the history you came from, but it would create a whole new timeline where things played out differently. It's both comforting and kind of overwhelming. On one hand, you can't ruin anything because every possibility already exists somewhere. On the other hand, there's an infinite number of yous out there making every possible decision you could ever make. Somewhere, there's even a version of you that nailed every single life choice. Lucky them, right? Number 9. The grandfather paradox. This paradox raises a question so bizarre it makes your head spin. If you went back in time and killed your grandfather before your parent was born, would you just cease to exist? And if you no longer exist, how could you have gone back in time in the first place? It's a logical nightmare, and yet, it's endlessly fascinating. Some theories propose a way out through parallel universes. If you off your grandfather, you wouldn't erase yourself, but instead, create a new reality where you never existed. Your original timeline stays intact, but you're no longer part of this new one. It's cold comfort, though, considering the implications of tampering with family trees. The grandfather paradox doesn't just challenge time travel, it questions the entire nature of causality. It's like the universe has its own set of rules, and we're just fumbling around trying to make sense of them. Number 8. The white hole theory. White holes are the cosmic opposite of black holes. Instead of pulling everything in, they blast matter and energy out. It's like the universe's way of balancing the scales. What gets sucked into a black hole might get spat out somewhere else. Some theories suggest that white holes could be gateways for time travel. Linked to black holes by wormholes, they could theoretically allow someone to enter one end and emerge in a completely different time or place. It's an enticing idea, but it's packed with challenges. For one, white holes are purely hypothetical. We've never observed one. And even if they do exist, the forces involved would be so extreme, they'd likely obliterate anyone who tried to pass through. But the concept is compelling because it hints at a universe with pathways and shortcuts we can't yet comprehend. It's less about practicality and more about exploring what's possible in the farthest reaches of physics. Number 7. The Tipler cylinder. The Tipler cylinder is one of the strangest ideas in the realm of theoretical physics. Imagine an infinitely long cylinder spinning at near light speed. The sheer momentum of this rotation would warp space-time, creating loops where time bends back on itself. These loops, called closed time-like curves, are the key to time travel in this theory. Enter the right spot in this warped space-time, and you might find yourself traveling to the past. It's a concept that feels as much like magic as science, but it's rooted in the equations of general relativity. Of course, there are hurdles. For one, building an infinitely long cylinder is, well, impossible. And even if we could, the forces involved would likely rip apart anything that tried to use it. But the Tipler cylinder remains a fascinating thought experiment, reminding us that time travel might not be about breaking the laws of physics, just bending them to their absolute limit. Number 6. Closed time-like curves. Closed time-like curves, in short CTCs, are one of the strangest ideas in theoretical physics. Imagine being able to trace a path through space-time that loops back to your starting point, but instead of just traveling in space, you also travel in time. It's as if you could leave 2025, travel back to 1995, and eventually end up back in 2025, like a cosmic merry-go-round. The tricky part is causality. In normal life, one event causes another in a linear sequence. But in a CTC, events can loop back on themselves. For example, what if your future self accidentally caused an event in your past without realizing it? It's not a paradox, it's just how the loop works. Some physicists speculate that these curves might exist in extreme environments, like near black holes. But whether they're real or just a mathematical curiosity, one thing's for sure. If time is a loop, we might be living the same stories over and over again without even knowing it. Number 5. Cosmic strings. Cosmic strings are thought to be the remnants of the universe's wild youth, thin, super-dense tubes of energy that stretch across the cosmos. These strings might not look like much, but their mass is so extreme they can bend space-time around them. Essentially, they're the universe's version of pulling a thread to warp the fabric. The theory is that if two cosmic strings ran parallel and close to each other, they could create a massive warp in space-time. This warp might be enough to allow time travel. Think of it as two highways running side by side, and you find a magical off-ramp that lets you jump into another timeline. The problem? Cosmic strings are theoretical. No one's actually seen one. And even if we found them, getting close enough without being obliterated by their gravitational pull would be tricky. Still, the idea of time travel hiding in the leftovers of the Big Bang is too fascinating to ignore. Number 4. Time machines. We've all imagined hopping into a time machine at some point, whether it's to fix a regret or just see the dinosaurs up close from a very safe distance. Movies make it look easy. Hit a few buttons, pull a lever, and voila. You're back in 1985 with Marty McFly. Real life, however, is far less forgiving. To make a time machine work, scientists think we'd need something called negative energy density. This bizarre kind of matter would act like a cosmic fuel, bending space-time in ways we can't even fully comprehend. The problem? Negative energy density is more hypothetical than practical, and even if it exists, there wouldn't be enough of it to power anything. Time machines remain the ultimate sci-fi fantasy. While we might never build one, the theories behind them keep pushing the boundaries of what we think is possible. Maybe the real magic isn't the machine, but the curiosity driving us to dream it up. Number 3. Traveling faster than light. The idea of traveling faster than light has captivated us since the days of Superman turning back time by reversing Earth's rotation. Spoiler alert, that's not how physics works. The real theory goes like this. If you could exceed the speed of light, time would essentially reverse, allowing you to travel into the past. Sounds cool, but there's a big problem. Einstein's theory of relativity says nothing can go faster than light. It's the ultimate universal speed limit. Even if we somehow broke that rule, it wouldn't be as simple as zipping back to fix your mistakes. There are countless other factors to consider, like the insane amount of energy required and the mind-bending effects of approaching light speed. You might end up traveling back in time, or you might just rip yourself out of existence. While it's fun to imagine outrunning light, this theory seems destined to remain in the realm of comic books and physics debates. Number 2. Have we already seen time travelers? Time travel might feel like fiction, but some people are convinced it's already happening. Take Charlie Chaplin's 1928 film, The Circus. In one scene, a woman walks by holding something to her ear. To modern eyes, it looks suspiciously like a cell phone, decades before cell phones were invented. Was she ahead of her time, or just weirdly scratching her face? Then there's The Simpsons. The show has predicted so many future events, from Donald Trump's presidency to the Cubs winning the World Series, that it's led some to believe the creators have access to a time machine. Either that, or they've got some seriously lucky writers. These stories are fun to ponder, but they raise an interesting question. If time travel is real, how would we even know? Number 1. Time as a fourth dimension. We're used to moving through 3 dimensions: forward, backward, left, right, up, and down. But what if time was just another dimension, and we could move through it as easily as we navigate a room? This theory treats time as a coordinate, no different from length, width, or height. It changes how we think about past and future. Instead of being something out of reach, they're just points along the timeline. To visit the Jurassic period or see what Earth looks like centuries from now, you'd simply shift along the time axis, just like walking to another room. But the real challenge is figuring out how to unlock that kind of movement. We're stuck experiencing time in one direction for now, but this theory offers a glimpse into what might be possible. It's not just about imagining time differently. It's about questioning whether the limits we feel are just our own perceptions. If you find this video informative and interesting, please like it, share it, and subscribe for more content like this. Thanks for tuning in, and we'll see you in the next one.